All right, recording is rolling. It is Monday, September 12th, and we're finally getting to the projectile lab that I've been wanting to get to. So we're gonna finish out projectile today and then start on forces tomorrow. Forget going too far on that though. Here's a top scientist for linear motion. And so if you see your name up here, it means you did really awesome on linear motion. If you got a little satellite, you did really, really awesome. If you want your linear motion quiz back, it's back in your folder. You guys have the blue name tags, and they're alphabetical. So A's over there, C's over there, Y's around, X's around. Right. I've had some students ask me, is there extra credit or any kind of opportunity like that? So here's what I'll do for that. If you handwrite corrections for all the problems that you missed and turn that in, then I'll give you a third credit back. So if it's a calculation type problem or a graph problem, then go ahead and like solve it or work it out, have equations to show you get some solution or redraw the graph. If it's one of those conceptual questions, then you can just go ahead and write out a sentence or explain why, like, okay, like this or that would be the answer, right? All right, so for example, if you got a 70 and you do the corrections on all the prompts you missed, then the third of what you missed, that'd be like 10 points back. All right, yeah. Right, a lot of you guys turned in your projectile homework, so taking that today. And then your projectile quiz, I'm picking that up tomorrow. If you want to turn it in early today, you can, but it's 2 days but tomorrow, so go with that. All right, launch lab. All right, so we've got these launch cannons. You can take these ramrods and you can see exactly what's going on here. Right, you press the spring. Actually, it'll click up to 3 times. So listen real close. So it's like click, click, click. Right. Probably for consistency, maybe as a control variable, however many number of clicks you have going on, just keep repeating throughout. So I just did 3 clicks there. Right. Then I can take this ball. Now there are different kinds of balls out there. This is like a spongy little bouncy ball with a mass of 6.4 grams. Some of you guys have a hard plastic yellow ball. That one's like 10 grams on the nose, but one or the other. Put it right here. Then, if I wanted to adjust the angle, well, doing a little overkill here, but do you guys see how you can actually adjust the angle? Right, and then there's this bob that hangs down through this built-in protractor. It tells you exactly how many degrees to the horizontal. Right. Okay, so you got the spring loaded, put the ball in. You could angle it to some angle if you want to change the angle. And then I'm gonna pull this and bam, out it goes. I wonder how fast that was. Well, there's different setups you can do to figure out the answer to that question. Here's the diagram I was showing to my AP students. Here's 3 classes setup, but help you guys out a little bit. Let's narrow it down maybe to this one, or tell you what, if you want to go off on your own unbeaten path and do your own way and call for the launch speed, you can. But I do recommend this one. All right, so did you guys copy? Are you guys copying this table down on paper? So you guys have this paper out. Write your name on your paper. Right, so you guys have paper out. Write your name on paper. If you don't have any paper, remember I got a stack of paper right here. Right. And then copy this table down. Okay, and then while you guys copying that down, go over a thought process to figure this out. All right, so a few minutes from now, we're going to head out to the balcony out there by the stairs, right, where there's a good drop-off ledge. Right, and I'm going to have you guys aim these launchers horizontally. You guys know, horizontal. Guys, horizontal, is that 0 degrees to the horizontal, right? That's like straight out, right? Guys, is horizontal mean you're gonna tip it up like at 45 degrees? No, this means going straight out, right? Now, you can do it this way, it's just a lot harder to solve in the end, right? But maybe I'll go over that later. But this is much more straightforward. This is much easier to solve this way. Just launch it straight out. And then, do you guys think if you know how far it drops in meters, like the height of this cliff, and you can spot the ball exactly where the ball lands, boink, and measure this horizontal displacement, and you also know Earth's gravity, do you think there's enough information there that you can, in principle, solve for the launch speed of this launcher? Think you can do that? Right? I think you can. So while you guys are thinking about how you could do that, and I'll walk you guys through this later here. Right? What are some good measuring tools? Well, one good measuring tool is maybe some kind of scale or balance so you can get the mass of this ball. Remember I told you guys there's two different kinds of balls out there. So the bouncy balls are like 6.4 grams, the hard ones are 10 grams. Okay. Oh, speaking of the balls, guys, here's a really important technical detail. It's gonna save some of you guys a lot of trouble if you're paying attention. Right? If you take this ball, don't do what I'm about to say. Don't do this. Don't put the ball in here and then take the ramrod and start smashing it. Especially if you have one of these bouncy balls, because it will get stuck and then it's a huge pain to get out of there, and then you'll be spending like half an hour trying to get the ball out. Okay. Instead, what you want to do is ramrod it first. Maybe I should have done 3 clicks to keep it consistent, right? Control variable. And then put in the ball after ramrodding it. Right. So let me see if you guys are following. What do you want to do first? Do you want to ramrod it first, or do you want to put the ball in first?
Ramrod.
Yeah, ramrod first, then put the ball in later. It'll save you a bunch of trouble down the line, especially if you deal with these bounce balls. Okay, something like that. Bam. All right. So, all right, measuring tools. Oh, do you think you could? Do you guys see these little speed gates around? Okay. Do you think you could put the speed gate right here and probably get a direct reading on what the launch speed is? You probably do that, right? Right. If you want to do that for fun, go ahead. I really want you guys to calculate what the speed is, but you know, if you want to treat this as like a textbook value or just see what the number is for fun, you can take this out. It's not officially part of the lab though. Right. Ooh, guys, what tool do you think you're going to be using to measure H and D? What tool?
Meter stick.
Meter stick. Good call. Meter stick. You can do the whole lab with the meter stick. You can get all the measurements you need, I should say, with the meter stick. You know what else I have? I have a trundle wheel. Oh yeah. This guy has a circumference of exactly 1 meter. So you can roll it and count off the number of meters. Right. I only have one of these. I'm gonna leave this right here. If you want it, you can pick it up. I only have one of those. Okay. How about this? Stopwatch. Do you guys think you need a stopwatch? Well, let's walk through this process of trying to figure out. Remember, you guys' ultimate goal is to figure out what the launch speed is saying. So we've got walk you guys through this process, and it's been a long weekend thinking about projectiles. Okay, and then think about what you would need. So, the fact that this cannon is aimed horizontally. Okay, so is this horizontal speed going to stay the same all the way across? Yeah, because gravity doesn't pull right and left, and we can probably basically ignore air drag. That's got to be probably negligible effect. So yeah, we're gonna say the blast speed is the horizontal velocity, and if that's true, then is this horizontal displacement divided by the time of fall just the answer to that question? Yeah. So in fact, if you know how many meters this is, and you maybe pull out the stopwatch and just divide those 2 numbers, that could do it for you, right? Okay. Now you might notice in this table, I didn't actually recommend doing that particular method because there's no time column here. I mean, if you want to do this your own way and go up a little bit off the beaten path, that's fine too. Right? But there's actually a much more accurate way to get the time, because one of the least accurate things you can measure in this class is using the stopwatch to measure time. Like when exactly do you start that stopwatch? Right? If you calculate the time, it's much more accurate. You guys see this height drop right here? Let's go back and review a really important projectile concept. If I launch a ball horizontally, exactly like I'm showing here, and at the same time just drop a ball, which one hits the ground first? Same time. Now, what that means, or what it sort of hints at, is that, maybe the time of fall is directly connected to the height of fall, right? Like if you know the height of fall and you know Earth gravity, do you think you can calculate the amount of time it'll take to fall at distance, right? Like for example, you guys remember if anything's been falling on Earth for 1 second, it falls about 5 meters. Right? So hold on that here. Hey, what if you knew this height of fall and you calculated the time that it was a projectile? Then you could take that calculated time, take this horizontal displacement divided by that, right? You guys see that? Get this divided by that time, right? All right, so I'm sort of giving away too much. I really wanted you guys to actually think about it a little more, but we'll go over this again after you guys get your data and come back in. What else I want to say about the I can forget something, but I think you guys get from there. All right, so you guys about ready to head outside here in a minute and grab some data? All right, so I'm gonna stop this recording, and you guys make sure you got all the equipment you want. You guys got your lab tables ready? All right, and stop recording.